this lesson, we're going to be looking at polynomial functions and how we can go about graphing them. And these graphs are not going to be as exact because there's some parts of it that we cannot get with just algebra. But we're going to get a picture of what the graph looks like. When we talk about polynomial functions, we're talking about functions in the form of f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1, and it goes on down to a sub 2x squared, a sub 1x plus a sub 0. Now basically this is only saying is whatever power you start with, like it could be x to the 5th, then you're going to decrease. We're going to have our highest degree first, which will be the degree of our polynomial. So this polynomial will be of degree n. And when we're talking about the a sub n, that just means this is the coefficient that goes with the term of the highest degree. This coefficient goes with the next term all the way down. A sub 2 is the coefficient that goes with the x squared term. A sub 1 is the coefficient that goes with the x, and a sub 0 is our constant. So we would say then that a sub n is our leading coefficient because it's the coefficient of the highest degree term. It's our leading coefficient. And with this, we can begin knowing some of the features of our polynomial function, and we're going to use something called the leading coefficient test. Now, polynomials that are of degree 2 or higher, and we've already talked about degree 2, those are our quadratics. Polynomials of degree 2 or higher are always smooth and continuous. Now what we mean by smooth is that we make gentle turns. We're not going to have any sharp edges as we do with our absolute value. Our curves are going to be smooth, and continuous means that there's no breaks. So you could actually draw this once without ever having to lift your pencil because of its characteristics. So this is something that we'll always see with our polynomial functions. They'll end up being what we would call smooth and continuous. Now, we want to look at what we mean with our leading coefficient test. It's going to give us the end behavior. What's happening to your graph as it goes toward infinity in the positive direction and as it goes toward infinity in the negative direction. We're not concerned with what's happening around the origin right now. We're only concerned with what's happening at the end. And what it turns out is if your degree is odd, if your polynomial is to an odd degree, so it's going to be x to the 3rd, x to the 5th, x to the 7th, and a is positive, then what's going to happen to our ends is it's going to go down to the left and up to the right. Now, as I said, I left a space there in the middle because we don't know what happens in the middle yet. We're going to find that out. If your leading coefficient is negative, then it's going to go up to the left and down to the right. Now sometimes instead of saying this, because normally we read our equations left to right, and so we wouldn't normally talk about something going down as it goes to the right, or up or left, and up as it goes to the left. But so sometimes it's easier just to draw a picture of what's going on rather than to write it in words. But the words we would use here is it falls to the left, rises to the right, rises to the left, falls to the right. Now, an easy way to remember this, when it's an odd degree, we've already studied linear equations. Linear equations are odd degrees. And in a linear equation, if your slope is positive, then your graph goes up as it goes to the right. If your slope is negative, your graph goes down as it goes to the right. And then basically all we're doing here is we're taking out part of the middle, because we don't know what happens in our middle here like we did with our polynomial functions, or as we did with our linear functions, excuse me. So if you can remember what happens to a line, then you can remember what happens to an odd degree. Now, if it's to an even degree, so it's 2, 4, 6, 8 would be your degree. If it's to an even degree and your leading coefficient is positive, then both ends will be going up. You'll be rising as you go to the left, rising as you go to the right. If it's negative, then both ends will go down. Falls to the left, falls to the right. Now again, we've already studied quadratics, and we know in a quadratic, if a was positive, it opened up. If a were negative, it opened down. And all we're doing with our polynomials is we're leaving out what's happening here in the middle. I erased a little bit too much of that one. But we're just kind of erasing then what happens there in the middle. And we're just dealing with what happens on the ends. So this is how we go about using our degree and the leading coefficient test to understand our end behavior. So let's look at a couple of equations. If we had the equation 2x cubed minus 4x squared plus 3x minus 5. And we want to know what happens at the end. Well, this is of degree 3. 3 is an odd number. Our coefficient's positive, so it's going to be the same as a line. It will fall to the left and rise to the right. If we had negative 4x to the 6th plus 2x cubed minus 3x squared plus 2, well, our degree is 6. 6 is an even number. Our leading coefficient's negative, so we're going to fall to the left and fall to the right. Just like a parabola would open down, this one's going to open down. If we have negative 5x to the 5th plus 4x squared plus x minus 6. Well, this is an odd degree. Our leading coefficient's negative, so we're going to be falling as we go to the right. So we'll rise to the left and fall to the right, just like a line would. And so this is how we can use our leading coefficient test to see about our end behavior. Now, once we know what's happening at the ends, then we can go back and start looking at, well, what's happening in the middle. And to know what's happening in the middle, what we need to know are the zeros. Now, we've talked finding the zeros. That's also the same as finding the roots or the solutions. To find the zeros, we're wanting to know where we cross the x-axis. Where we cross the x-axis, we know that y is 0. So if we're given the function f of x equals x cubed plus 2x squared minus 4x minus 8. And we want to know what the zeros are. Well, we're wanting to know, well, when is y 0? So we're going to take our equation and set it equal to 0. Now, with 4 terms, the method that we learned to solve this by was factoring, and we factored by grouping. So in our first group, we can factor out an x squared. X squared times x is x cubed. X squared times 2 is 2x squared. Minus 4, we can factor out a negative 4. Negative 4 times x, negative 4x. Negative 4 times positive 2 is negative 8. Now we have a common factor of x plus 2 times x squared minus 4. Then we set each factor equal to 0. So we get x plus 2 equals 0, or x squared minus 4 equals 0. Subtracting 2, we get x is negative 2. We would add 4, and then take the square root of both sides. Remember, when we take the square root, we always say a plus or minus, and the square root of 4 is 2. So we have these as our solutions. Now in just a few minutes we're going to come back to this problem and we're going to graph it using some techniques that we'll discuss in just a minute. Let's look at another problem. Let's say that we have f of x equals x to the fourth minus 4x squared. Well, we want to solve it, so we're going to set it equal to 0. And again, we can factor out a common factor of x squared and have x squared minus 4. Setting each factor equal to 0, here we would get x is 0, and x squared minus 4 equals 0. So x squared equals 4, or x equals plus or minus 2, the square root of 4. And again, we're going to come back and graph these in just a minute. But that would be finding our zeros. We just go through the same methods that we've already done on factoring, and these are going to be factorable in this stage. We'll get to some problems in a few lessons that we can't factor, and so we have to go about solving them using some other tools. Now, if you noticed in some of those problems, we ended up with our answer more than once. Back up in this one. If you notice, we had an x squared. So we actually ended up with 0 as an answer twice. If we looked at this one, we have an x equals negative 2. Down here we have another x equals negative 2. So sometimes you have an answer more than one time. And when you do, it's going to help you know what happens when you get to the x-axis. Remember, these are zeros, so this is where you are when you're on the x-axis. And so what we're going to deal with here is our multiplicity. That's how many times you have a solution. Well, if you have a solution or a root or a 0, if you have a 0 an even number of times, if we have a 0 an even number of times, then what's going to happen is our graph, I like to use the term bounce. Our graph will bounce when it hits the x-axis. You might also say it touches and turns. But when it hits the x-axis, what it's going to do is go right back down. Like it ricochets off of the x-axis. So it bounces off of it, or it touches it and turns when you have a 0 an even number of times. If you have a 0 an odd number of times, then it's going to cross the x-axis. So when you get to the axis, to the point where you had your 0, then you'll simply cross the x-axis. And so that helps us then as we go through and we graph it. So let's go back to this one, and we're wanting to graph it. Now, if we look at what we have an odd degree. So our degree is 3. So we have an odd degree, and our leading coefficient is positive. So that means our end behavior, we're falling to the left and rising to the right. So that's what's going to happen at the end. We're going to fall to the left and rise to the right. So if we go down to graph this, then we know that this is what's happening at our ends. Now, to know what's happening in the middle, we look at our solutions. We have x equals negative 2. Now, we had it 2 different times. So we had it to a multiplicity of 2, which is an even number. So that means our graph is going to bounce here, or touch and turn. Then we have a positive 2, and we have it as a solution 1 time. Now we could on this problem, we can't on every problem easily, but on this problem, we can know where we cross the y-axis. We cross it at negative 8. If x is 0, then y is going to be negative 8. So there's another point that we have. And so at negative 8, we know we're going to cross the y-axis. Now, this is all that we have, are these few points. So what we know is at this point, we're going to bounce. So we're going to be coming up. We're going to bounce. Now, somewhere along the line, we're going to cross. And we know that we're going to have to turn because we've got to get back up to this point. So we're going to turn. We're going to go up to that point. We have that answer 1 time. So we cross here. We cross at positive 2, and we just keep going to our end behavior. And this gives us a good picture of our graph. Now, if we wanted to, we could take our calculator and actually graph this equation just to check out what we have. So we would have y equals our x cubed plus 2x squared minus 4x minus 8. And then we could graph it. And you can see that our graph here looks very similar to the graph that we had. If we pull it back up. So we can see that it's pretty close. We just need to resize this where we can see both of them. So you can see that our graphs are very similar. Now, some of the things that we can't do with this method that we're dealing with, we can't know where we turn. When we don't turn at a point, we just know that we turn because we have to get back up to this point. We can't know where that is. Some of those things about knowing where you turn, that would be when you move on into calculus. So we're not going to be able to know that, but we do know that we turn, so we can just get a general picture of our graph. Let's look at the other one that we did, and let's go through and graph this one. Now on this one, our degree is 4. So if we're to the 4th degree, that's an even number. Our coefficient is positive, so that means that our ends are rising in both directions. So if we want to graph this, now we have a solution of 0. We have it 2 times because this is x times x, so we have x equals 0, x equals 0. So we know that we're going to bounce here. Or again, some people call that touching and turning. We know that we have a solution of negative 2. We only have it 1 time, so we're going to cross there. And we have positive 2. We only have it once, so we're going to cross there. Now our end is in this direction, so we're going to be coming down. And at negative 2, we will cross. Now somewhere we have to turn because we have to get back up to 0. 0, we have it twice, so when we get there, we're going to just turn again, or bounce. Then again, we have to turn so that we can get back up to this point, and then we're going to keep going. Now, our number of turns, the number of times that a graph can turn, is determined by the degree. Any graph can turn n minus 1 times. So since this was to the 4th degree, the most number of times that we could turn in this graph would be 3 times. We don't have to turn 3 times, but that would be the most that we could turn. And we did. We turned 1, 2, 3 times. In the other one that we did, our degree was 3, so the most number of times we could turn would be twice. And we did. 1, 2. So the number of times that your graph can turn is 1 less than the degree. So if we want to know about the number of turns, it's 1 less than the degree. That's the most that it can turn. And again, it doesn't have to turn that many times, but that's the most that we can turn. And then let's just go ahead. The number of roots that a polynomial can have is n. Now, all of these roots don't have to be real roots. Real roots are the only ones that we can graph. And so those will be the ones that we will be concerned with. Those are the ones that we can graph. But that's the number of roots that it can have. So we've got a lot of information here. We know about our end behavior. We know whether we cross or bounce at our zeros. We know how many times we can turn. And we know how many roots we're going to have. Let's look at another one and go through and graph it. We've got f of x is equal to negative 4 times x plus 1/2 squared times x minus 5 cubed. Now this one's already factored for us because at this stage we don't know how to factor it. And we'll look at some techniques in the next few lessons that will help us in finding these roots, but at this point it would have to be factored for us. Now let's talk about the end behavior. To know the end behavior, we have to know the degree. Well, this isn't written in the form of a polynomial of something, n to some, or x to some power plus x to the next lower power all the way down, where it's a sum of our monomials. This one's written as a product. It's in factored form. But let's just look at this. If we took this binomial and we squared it, we know that we would have x squared plus something, some other terms. But we would have an x squared. If we took this one and cubed it, well, we'd start out, we'd have an x squared, and then that times x, we would end up with an x cubed as our highest power for this one once we cube this binomial. Now, when we multiply like bases, so then when we multiply those two answers together, when we multiply like bases, we add the exponents. So this polynomial, if we multiplied it all out, it would be of degree 5. So now we know our degree. We need our leading coefficient. Well, all of these would have been x to some power because they have a coefficient of 1. So then when we distributed our negative 4, then our leading coefficient would be negative 4. So we have an odd degree with a negative leading coefficient. So that means that our ends would be falling. So that would be our end behavior. Now we need our solutions. So we're going to set our polynomial equal to 0. And we know that negative 4 doesn't equal 0, so we don't have to deal with it. But x plus 1/2 could equal 0, or x minus 5 equals 0. So here we would subtract 1/2, so we get x equals negative 1/2. Now, we would get that answer 2 times. because this is x plus 1/2 times x plus 1/2. So this had a multiplicity of 2, which means we're going to bounce here. This one we would add 5, so we get x equals 5, but we would have had that answer 3 times. So this one has a multiplicity of 3, so we're going to cross here. The most number of times that we can turn is 4. It's 1 less than the degree. So if we graph this, we have negative 1/2 and 5. Okay, we're coming down to negative 1/2, and when we get there, we're going to bounce. And we'll go up. We don't know how high we go up. We don't know where we cross the y-axis here. That would be fairly difficult, although we could figure it out. We're going to have negative 5 cubed, so that's a negative 125. This we would end up with 1/4, so when we multiplied it by negative 4, that would be negative 1. So we're going to end up way up here at positive 125. But at this point, we're not as concerned with that, and we wouldn't be able to graph it on our graph. So we're just going to say we go up real high, and at some point we turn because we know we come down to 5, and at 5 we're going to cross and continue down. So all we saw our turns were twice. It's possible that our graph may have turned again somewhere along the way. We might have gone up and curved down and then gone back up and curved. We might get here, we might curve up a little bit and then curve back down. We can't tell with just what we know. To be able to tell those things, we would have to move on into algebra. Into calculus. So let's look at another one. Let's say that we have f of x is equal to x to the 4th minus 6x cubed plus 9x squared. We want to graph this one. Well, we need to set it equal to 0. We can factor out a common factor of x squared. So we'll have x squared minus 6x plus 9. We can factor this polynomial. It would be x times x. We need factors of 9 that add to be 6. Well, that's 3 and 3. The signs are the same. They're both negative, or you could write that as a binomial squared. Then we'll set each factor equal to 0. So x squared equals 0, so x equals 0, with a multiplicity of 2. We have x minus 3 equals 0, so x equals 3. Again, that's with the multiplicity of 2 because we had it twice. So we're going to bounce at both of these places. Now, if we draw our graph, let's look at our end behavior first. This was an even degree and a positive coefficient. So that means our ends are rising in both directions. We have roots at 0 and at 3. We're coming down at 0. We're going to bounce. Somewhere we have to turn because we've got to get back down to 3, and we bounce there and we continue on. And so again, we've got a picture of our graph. If we wanted to check that, let's just look at the calculator and see what we would get there. So let's put this in. We had x to the 4th Let me go back here. We've got x to the 4th and minus 6x squared, 6x cubed, excuse me. plus 9x squared. And if we graph it, okay, we can see that our graph looks very similar to what we did. So it's a quick way of getting a good picture of your graph. Now what you may be saying is, well, I could just graph it on the graphing calculator and then copy it. But you don't have the same feeling for the graph, the same understanding of what's going on and what can happen. So it's really important that you learn to graph these and learn to be able to look at your information and analyze what's going to happen without having to graph it. And so some of the things about your ends before you could ever get it into the graph. So it's really important to be able to do that. All right, let's look at one last one to graph, and then we've got one other thing that we want to look at. So let's take this one, f of x equals -3 x cubed times x minus 1 squared times x plus 3. Now, it's already in factored form, so we're going to set it equal to 0. And we can solve. We've got x cubed equals 0. So x equals 0 with a multiplicity of 3. So that means we're going to cross at 0. We have x minus 1 equals 0. So x equals 1 with a multiplicity of 2. So it's going to bounce there. We have x plus 3 equals 0, so we have x equals -3, and that's one time. Now, we need to know what's going to happen at the end. Again, you're going to have to figure up the degree. We have an x cubed times an x squared times an x. When you multiply like bases, you add the exponent, so that would end up to be x to the 6th. Then we would go back and multiply that by -3, so our leading coefficient is -3. So we have an even degree with a negative coefficient, so that means that our graph's falling in both directions. Okay, our solutions are 0, 1, and -3. Okay, we're starting at -3. We come up and we cross because we only have that once. Somewhere we're going to have to turn. We come back to 0 and we cross there because we had it an odd number of times. We have to turn to get back to 1, and that had a multiplicity of 2, so we're going to bounce, and then we will go in that direction forever. So that would give us an idea of our graph. If we wanted to put that into the graphing calculator just to see what happens, we've got y equals -3 x cubed x minus 1 squared and x plus 3. And we can graph. Now you can see our graph goes up real high. It's off our screen, and that's okay. We don't really know, and we're not worried right now at this point how high it goes. And then it comes back down. It's a little hard to see there, so we could zoom in to see what happens as we get down here. So we've come down. You can see we cross at 0. We turn, we go back up, and then we continue down. And so we've got a good picture then of what our graph did. Now, if you remember, it came down real steeply when we had the other part. And so we've got a good picture of our graph. So these are some of the things that we can do as we work with our graphs. One other concept that we want to look at is called the intermediate value theorem. And the intermediate value theorem can sound really difficult when you first read it, but it's an easy one to understand. Okay, let's look at the intermediate value theorem. What it says is, let f be a polynomial function with real coefficients. If f of a and f of b have opposite signs, then there is at least one value of c between a and b for which f of c equals 0. Therefore, the equation f of x equals 0 has at least one real root between a and b. Now, that sounds a little complicated, but when you look at it, what it's saying is, if we have a polynomial function, some f of x, and we have points a and b, and the y value for this a, so when we plugged it into our function, into our f of x, when we plug a into there, this is the y value we get. Let's say it's positive, so this is f of a. And when we plugged our b into our function, we got some negative number, so this is our f of b. Then common sense would say that somewhere between a and b, we've got to cross the x-axis. So we have some point c where f of c is 0. We have a root. We have a solution between those 2 points. And sometimes this is what you have to do to narrow down where your root is. You may know that you have a positive answer one place, a negative, and so, well, at least it's between these 2 numbers. I don't know exactly what it is, but I can get you the general idea. So if we look at an equation, let's say that we've got the equation f of x equals x cubed minus 4x squared plus 2. And we want to know, is there a solution, is there a 0 between the numbers 0 and 1? Well, to know that, what we do is we find f of 0. Well, that's going to be 0 cubed minus 4 times 0 plus 2 is 2. Then if we find f of 1, well, we have 1 cubed is 1. 1 squared is 1 times negative 4 is negative 4 plus 2. And so this gives us negative 1. So for 0, we had a positive 2 as an answer. For 1, we had a negative 1. So that says that somewhere between 0 and 1, we have a solution. If we graphed that, at 0, we're at 2. At 1, we're at negative 1. So you can see somewhere between 0 and 1, we have to have a root. Now, let's just go ahead and see, well, what about f of 2? Well, 2 cubed is 8. 2 squared is 4 times 4 is 16. Plus 2, this would be negative 8 plus 2 would be negative 6. So you can see at the next integer, we're still negative. So that means we didn't have a root between there. But let's go back up here and do f of negative 1. Okay, if we cube a negative 1, we get a negative 1. Negative 1 squared is 1 times negative 4 is negative 4. Plus 2, well, we have negative 5 plus 2 is negative 3. So we also have a root between 0 and negative 1. Because at negative 1, we're back down here to negative 3. So somewhere between 0 and -1, we had to cross the x-axis, and therefore we have a solution. So we're going to use the intermediate value theorem a good bit as we go through and begin solving our equations. So what you need to be able to do is solve equations, or you need to be able to graph equations. You need to be able to know what the end behavior is doing by the leading coefficient test. You need to know what happens on the x-axis, whether you cross the x-axis or whether you touch and turn, or not called bouncing. You need to know how many times an equation can turn, and you need to know how many roots there are. And this will all help us as we go through and begin graphing our equations.